This is the Unit 3 Lesson 7 video, and we're in Chapter 7, Section 7 out of the textbook, and this lesson is talking about base E and natural logarithms. The content standard for this lesson is use the structure of an expression to identify ways to rewrite it, and the mathematical practice is to look for and make use of structure. Back in Lesson 6, we worked with common logarithms, and in this lesson we're going to evaluate expressions involving the natural base and natural logarithm and solve exponential equations and inequalities using natural logarithms. The natural base is known as E. You've seen E a lot before in math classes. The natural base exponential function is a new vocabulary term, and natural logarithm is also a new term. So the natural base function. The function f of x equals e to the x is used to model continuous exponential growth. We've seen e to the x and e to the negative x before for growth and decay. The thing is now that we're going to realize that e is the natural base. It's called the natural, and the inverse of a natural base exponential function is called the natural logarithm. This logarithm can be written as log base e of x, but it is more often abbreviated as ln x, standing for natural logarithm. Notice from these graphs here for exponential growth that the e to the x function looks like this blue line, and the inverse of that, the natural logarithm of x, looks like this red line. And for exponential decay, the blue line is our exponential decay, and the red line is our negative natural log decay. So for our first example, we're going to write an equivalent logarithmic equation for e to the x equals 23. What's our value of x? To find e to that power would give us 23. So the first thing we're going to do, just like we did back in lesson 6, is we're going to take the log of each side. And actually what we're doing here, what they're doing is just taking the exponential form and rewriting the exponential form back in log form. So we know that when we have e to the x equals 23, that's going to be the log of e, log base e of the answer, 23, equals x. So e to the x equals 23, just like we've looked at in previous lessons. But then we're going to abbreviate log base e as natural log. So this just says natural log 23 equals x. That is our equivalent logarithmic equation. Okay, part B, we're going to write an equivalent logarithmic equation for e to the 4th equals x. So again, what we're going to do is to convert this into log form. So we'd have log base e of x equals 4, and then converting log base e to natural log. So our final equation is natural log of x equals 4. And this is pretty simple so far. I'm going to jump ahead and go to example 2. Skip the check your progress problems. Oops. Okay. Example 2, we're going to write natural log of x is approximately equal to 1.2528 in exponential form. So to do this, what we're going to do first is convert natural log x to rewrite it back as log base e, and then we're doing e to this power is approximately equal to x. So our answer here is just x is approximately equal to e to the 1.2528 power. For part B, we're going to write natural log of 25 equals x in exponential form. So again, we're going to convert natural log, we're going to write it back in log base e form, which would say e to the x equals 25, and this is our answer, e to the x equals 25. You can look at check your progress real quick, but I'm not going to spend much time on this. The answer this time is choice B, part B. Here's another equation, and our answer this time is A, 47 equals e to the x, or e to the x equals 47. Okay, for example 3, we're going to write 4 natural log 3 plus natural log 6 as a single logarithm. So we're going to have to draw on our properties of logarithms back from lesson 5. The power property lets us convert 4 log 3 back to log of 3 to the 4th, right here. And then remember that when we have a log plus a log, we use the product property and we convert that into a single log of the first thing times the second thing. And 3 to the 4th power times 6 is 486. So our final answer is natural log of 486. Just if you want to check your answer, you would type 4 natural log 3, close your parentheses, plus natural log 6, close your parentheses, hit enter. And then also check natural log of 486, close your parentheses, hit enter, and you'll get 6.1862 for each of these expressions. Part B, we're going to write 2 natural log 3 plus natural log 4 plus natural log y as a single algorithm. So 2 natural log 3 is the same as natural log of 3 squared. Then we have the sum of 3 logs, so we can make that a single log of 3 things multiplied together. 3 squared times 4 is 36, 36y. Final answer, natural log 36y. Check your progress. We're going to do 4 natural log 2 plus natural log 3, and the answer to that is natural log of 48. And for part B, 3 natural log 3 plus natural log of 1/3 plus natural log of x is going to come out to be natural log of 9x. Okay, example 4. We've got an equation this time to solve. It says 3e to the negative 2x plus 4 equals 10, and we're going to round to 4 decimal places for our answer. So the first thing we want to do with this is subtract 4 from each side. Then we're going to divide each side by 3. Then we're going to take the natural log of each side, right here. Then we remember that with the property of logs, we can bring the negative 2x down in front. The natural log of e is defined to be 1. So this is just negative 2x times 1 equals natural log 2. We're going to divide both sides by negative 2. We're going to type this number in the calculator and get our answer. That number comes out to be negative 0.3466. So that is our final answer for x. Here's another problem. 2e to the negative 2x plus 5 equals 15. Our answer for this one is choice A. Your process for this, again, you're going to subtract 5 from each side. Then you're going to divide by 2. Then you're going to have, let me type this in here, natural log of e equals, oops, let me back that up, negative 2x times natural log e equals natural log of 15 minus 5 is 10, 10 divided by 5, 2 is 5, natural log 5. We're going to have that line. And then remember that natural log of e is just 1. So that's going to be negative 2x equals natural log 5. Then we're going to divide both sides by -2, and we're going to have x equals natural log 5 divided by -2, and type that answer in our calculator, and we're going to get this choice A. All right, example 5, we have the equation 2 natural log 5x equals 6. We're going to round our answer to 4 decimal places. So here, first thing we're going to do is divide both sides by 2. Then we're going to we're going to have e to each side. We're going to use, that's the property of equality for exponential functions. So we're raising each of these things with e as the base. E and natural log cancel each other out. This just becomes 5x equals e to the third. We're going to divide both sides by 5. Put this in the calculator, e to the third power divided by 5, and you should get 4.0171 as your final answer. For part B, we have an inequality, the natural log of the quantity 3x plus 1 squared greater than 8. We're going to round to 4 decimal places in our answer. Okay, so the first thing we're going to do with this problem is raise each of these sides of our inequality as exponents with e as our base. Then e and natural log cancel each other out. We're left with 3x plus 1 squared. We're going to write e to the 8th as something squared so that we can remove the squares from each side. And we know e to the 8th is the same as e to the 4th to the second. 4 times 2 gives us 8. Now we both have squares on each side, so we're going to drop the squares. And we're left with 3x plus 1 is greater than e to the 4th. We're going to subtract 1 from each side. So we have 3x greater than e to the 4th minus 1. And then in our next step, we're going to divide both sides by 3. We're going to put this in the calculator, e to the 4th minus 1, and then divide that by 3, and we should get 17.8661. So our answer is x greater than 17.8661. Just real quick, this one, 3 times ln 6x equals 12. Answer for this is choice C. And then part B, this should be ln, not in, but ln 4x minus 2 greater than 7. When you solve that, you will get choice A, x is greater than 274.66. Okay, we're going to pause here and pick up with continuously compounded interest in the next video.